All right, we're recording. Thank you. Good morning. My name is Chris Rocky. I'm the district hydraulic engineer, and this time I'm going to talk with you about the spread and depth of flow on the shoulders and also ditches and channel calculations. With that, we'll just go ahead and get started. I'll share. Here we go. Spread and depth of flow. And the spread and depth of flow that we're interested in is what's going on the shoulders. Is it going to spread out too far into the traveled lane before it actually falls into the drainage inlet? And then will the drainage inlet intercept all of it before it continues on? What we're looking at today is to make sure it doesn't spread into the traveled way or get too high that it overtops the curb and goes someplace else. Our standard cross section, we have a 2% slope and usually a 5% shoulder, and then the curb and gutter is here. We're trying to keep, in this case, we want to keep the flow within the curb and gutter. We wouldn't want to go into the traveled way. And here we're a close look at the shoulder. The red line on the left here is the edge of traveled way. We don't want the flow to go beyond the edge of traveled way into the traveled way. And we don't want it to get any deeper that it would overtop this dike and maybe go down the hill and cause some erosion. Again, this is just our standard tangent section, then the super elevation section. The standard tangent usually will spread into the traveled way before it overtops the dike. And then for the super elevation, it will overtop the dike likely before it gets into the traveled way. Unless you're about ready to super the other direction, and then it'll be pretty flat in that area. Again, with our drainage reports, we have to summarize our work in the drainage report so somebody in the future can follow what we've done and duplicate it. I always start with these summary tables of the information that you're going to put into Flowmaster to do the calculations, and then there's spaces here for you to put the results from Flowmaster as you come out of as you get the results. Starting over here on the left, the drainage system location 1E. For example, if you have a DI that is numbered at 1E, then you would want to know what the spread and depth of the shoulder is right as you approach that DI. And then this is the watershed location. Again, just a rough location so they can see where you're looking. Are you looking on the left or the right hand side for that watershed? The Q that you're going to use. And for spread and depth, 45 miles per hour is our deciding factor on which Q we're going to use. If the speed limit is 45 miles an hour or less, then we use a 10-minute time of a 10-minute flow, or a 10-year storm. If it goes above 45 mile an hour, then we use a 25-year storm. In this case, we're using a 10-year storm, and the Q for that. The cross section measured, you're going to need to measure a cross section just before the drainage inlet. You usually have available a series of design cross sections cut every 25 or 50 feet or so. And I select the cross section that's the closest to that DI or the point of interest that represents what's going on at that shoulder. And those cross sections, you might recognize them. The design cross sections usually look something like this. And then the available depth, I'll show you how we get that. And then the normal is what we calculate, and that'll come out of Flowmaster. There's a quick check to make sure that you haven't exceeded what's available. And again, for the spread, there's the available. I'll show you how to get that. And then the top width is what comes out of Flowmaster. And then a quick check to make sure that that's not going to exceed. And then the velocity that you're going to get out of Flowmaster, and the material, Manning's N will come out of Flowmaster. And then the channel slope for Flowmaster, you're going to need to know the longitudinal slope of the channel or of the shoulder. So pick a couple of those design cross sections and just measure along the flow line there. And ultimately what you need is the slope. And if you already know this longitudinal slope, you can hard type that in and skip these calculations if you need to. Again, all of these columns are optional and you can use what's appropriate for your project. There's the design cross sections that we go to. When you zoom in tightly on the shoulder of the design cross section, we're interested in the two red lines on the top. The very top one is a straight level line out from the ETW. And in this case, it would overtop the dike. And we don't want a design to overtop the dike. So we wouldn't use the top line. And in this case, we would draw another line from the top of the dike, straight and level across till it intersects. And then that red line right there becomes the spread, because it's not going to spread into travel way and it's not going to overtop. And then the depth right here to the flow line, that becomes the depth. A closer view here, this red line is the spread, and then this one would be the depth. And then I'll come back to this one. We'll go ahead and again, we have the green line, which is the shoulder. We're going to model this shoulder now in Flowmaster. And before we get into Flowmaster, I want to describe a couple of different drainage inlets to you. Excuse me. There's two main drainage inlet types that we use. One is just a plain grate, 2 feet by 3 feet, and that's what we're looking at here. Another is a grate and the opening on the curb. The grate itself is a G1 drainage inlet. And then we come to the curb opening, and there you have the grate and the opening, and that's your GO, stands for grate opening. Excuse me, another example of that. And then here is an example of a double grate. Instead of 4 feet or 2 feet wide, now this one's 4 feet wide by 3 feet long. And there may be a case where you need to double your inlet in order to get the spread or the interception that you need. We'll go ahead and look at Flowmaster. And in Flowmaster, when you open up and you come to this screen here, on the left-hand side, it gives you a couple of different options to select from in the calculations you want to do. Channels, pipes, weirs, orifices, and inlets. In the calculations that we do, we only use Flowmaster for the inlet interception. That's the bottom one here. And then today, the channels. The others we don't come to Flowmaster for. Now, when you come to the channels, the shoulder is essentially a channel from the dike over and across the shoulder is essentially a channel. So that's what we're looking at. Flowmaster gives you a couple of predetermined channels that you can use, say for example a straight V ditch or a trapezoidal ditch, and they're predetermined and you can just fill in the blanks. It's acceptable to use those. However, what I've done, and I always do, is I just come to the irregular channel, and this one you can build a custom channel to match exactly what you've got, to represent what you have in the field. The other ones with the predetermined, you might have to make those fit. Once you select the irregular channel, here on the left-hand section is the title of it. And it's also going to be the title of the report when you print out the report at the end here. So you'll want to title this something like the location of the shoulder, maybe that, for example, the DI1E. proposed spread, DI1E, and then the event, either the 10-year or the 25-year event. And then after you've got it titled, coming over here and looking to fill in the blanks, we have three tabs. The one that we focus on is the first one. And we're not going to solve it for discharge. We have a couple of different options to solve for. You can solve for any of these if you need to, but we focus on depth. We're solving for normal depth. And the yellow boxes are the calculations, and you'll get the results there. The channels, the white boxes are what you're going to need to fill in yourself. And then the discharge, and then the other tabs here, you're not going to use these, so you will just forget. This one is notes. You can leave notes to yourself or somebody in the future if they want to read this, but honestly, nobody does. And coming back here to the beginning, we have the roughness coefficient will be given to us. And then going back to that spreadsheet, the channel slope, that channel slope was 0.012. And then the elevations, that'll be defined for us. And then the discharge that we had on that spreadsheet was 1.2 cubic feet per second. Those are the only two things that you need to put in right now, but now we need to define that channel. And that's this one. Flowmaster is going to ask for the station and elevation. And when they ask them for the station, it's not the station that you and I are familiar with in highways. It is the station across the page. When you're looking here, you have a grid. This is the 0 station, and then you measure across the sheet for the next station. So you'd have the 0 station. In this case, this one right here would be station 0.2, and over here this would be station 0.6, or excuse me, 6.0. And then the elevation for this green line is going to be 0.3. And so what we're going to draw is this heavy white line. We're going to draw that in Flowmaster. So when you come into your design cross sections, ultimately what you're going to want to need is what is the height to that green line, and then what are these stations right here. Now we'll go back and look at Flowmaster. And in here, we have to draw that section right here in the bottom left. It says edit section. And here it's asking for the station and the elevation. We're going to have, I think, 3 inputs, so I'll go ahead and put 3 here. The first station was 0, but the top of that dike was 0.3, so we'll have 0.3 in this column. And then the next station over, so the bottom of the dike there was 0.2, so we'll put the next station over as 0.2. And then the elevation there was 0. We're going to assume that the flow line elevation is 0. And then for the last one, the station over is 6 feet. And that's 6 feet from the beginning, not 6 feet from the flow line. So it would be 6 feet over. And then the top elevation that we're interested in, again, is 0.3. Because if it goes above 0.3 now, it's going to overtop the dike. And at that point, we'll have to change something. There's our roadway cross section. This is not necessarily shown to scale. Now the nice thing about doing it with the irregular section is you can assign a different roughness coefficient to each length. And say, for example, you had concrete curb and gutter, a concrete curb right here, and then asphalt shoulder, or even asphalt shoulder and earthen fill right here. So you can select different materials. So in order to do this, we come up here to the top. We select the first station that we're interested in. In this case, we have, and it automatically selects the last station for us. And the roughness coefficient that we're interested in, A dike, a dike's made out of asphalt, so we select the materials, come to material library, and we're looking for the type of material that we want to use: asphalt pavement, asphalt. I, I select asphalt rough. I don't select smooth. If we put it out there brand new, it's only going to be smooth for a while until the weather roughens it up. So I do my calculations with the rough unless you have a reason to go otherwise. And then here it gives us the Manning's coefficient, so we select OK. And there's the one answer that we're going to need for our spreadsheet is the 0.16. And then to do that assigned the whole green line as a 0.016. Now we want to assign this one as, we did this as asphalt. We want to do this as concrete. And now we take the next section. So what it's saying from here to here is going to be asphalt. And now we'll define from here to here. And we're going to change that to concrete. Oh, there they are. Concrete wood forms. And then you can have broom, trowel, different finishes here. I usually go with wood forms. Gives us another roughness coefficient. Now we're done. The green line on both sides, we have a roughness coefficient for asphalt here, a roughness coefficient for concrete here. We're done. It's all green. We select OK. It's actually done the calculation for you already. And the way you see the results are, we were looking for the top width, and we know that we had 6 feet available, so we've got 4 feet there, so that'll work. And the depth, it's saying it's 2.7 inches. We have 4 inches available, so this is going to work for us. And you want to carry these over into the spreadsheet, and I'll show you that in a moment. And then to get the visual answer, come up here to the cross section. This is the report that you're going to want to save for the drainage report. And here you can see the cross section that we drew, and the blue line represents the flow, the top of the water. Now, if this blue line gets above these green dots, then it's above the dike, and it's not going to work for you. You'll have to find something to do to reduce to change that. Make a smaller watershed, for example, or something to reduce the flow. And then once you're at this look, you're happy with this, then you can print this out to PDF and you're done. Now we'll go back to here. Here's our spreadsheet. It was asking for the normal depth, and here's the normal depth. But I have noticed just now, as a matter of fact, that normal depth is reported in that spreadsheet as inches. And here in my spreadsheet, it's in feet. So in one of the updates to Flowmaster, they've switched here. So be careful of the units that you're looking at and make sure that that works for what you're looking at. And then here is the top width, and then it's making a comparison for us, and here it worked okay. We can get the velocity out of that report as well. And then here is the Manning's end that you ended up using for that, and that was the combined Manning's end from the two sections. And then this was your flow calculations, or excuse me, your slope calculations. And so that essentially covers the spread and depth on the shoulders. If the shoulders, if it's too wide and it spreads too much, then you either need to add another drainage inlet to reduce the size of the watershed, so you can, and usually what I do is just split it in half, see if that's going to work for you, and then just keep splitting it down that way until you get a size that does work, and then space the drainage inlets that way, or some other way to make it another smaller watershed. With that, that's the spread and the depth of flow on the shoulders. Now, the dike, or excuse me, the ditches and channels, it's the same thing. You have the station and elevation right across here. You do the same thing for station and offset and elevation, and everything else is the same. The flow for the flow line of the gutter up that we do for our calculations, you would use the slope here of the channel instead of the slope of the flow line. So essentially, it's the same calculations you have there. And I think that is the end of the presentation. And with that, I'll go ahead and I'll leave this up, and I'll take questions if anybody'd like to ask anything. I don't see any hands. Wow, did that make sense? Okay, Jason, thank you. Well, I'll tell you what, I'll go ahead and stop